Hello students. So today's topic is insertion and deletion algorithms in queue. As we have already discussed queues in my previous lecture, an insertion and deletion is done at two different ends in a queue, that is front and rear. Insertion is done at rear and deletion is done at front. So far when we have to insert an element in a queue, we will increase the rear by 1, rear equal to rear plus 1, and when we have to delete an element from a queue, then we will increase the value of front, that is front equal to front plus 1. And if the value of rear is n and we have to insert an element in the queue and we have the space in the queue, this queue is not full, then we will assign value to the rear is 1, that is rear equal to 1. And if we have to delete a element in a queue and the value of the front is n, then again we will assign 1 to rear, that is 1 to front, that is front equal to front, front equal to 1. So a queue is a linear list of elements in which deletion can take place at one end called the front and insertion can take place at the other end called the rear. The terms front and rear are used in describing a linear list only when it is implemented in queues. So the terms front and rear are only used in queues. So queues are also called first in first out list. We call them first in first out because the first element which comes in the queue will be the first to which will go out of the queue. Since the first element in a queue will be the first element out of the queue. In other words, the order in which elements enter a queue is the order in which they leave. This contrasts with stack which are last in first out or LIFO lists. So example of a queue: queues around in everyday life. The automobiles waiting to pass through a intersection form a queue in which the first car in line is the first car through. So the automobiles waiting at a red light, they also form a queue. The people waiting in line at a bank form a queue where the first person in line is the first person to be waited, and so on. An important example of queue in computer science occur in a time sharing system in which program with the same priority form a queue while waiting to be executed. So in a time sharing system, for example, a hardware or software is used by different programs and all the programs have same priority, so they form a queue. The program which is first in the queue will get the hardware or software resource first, and so on. So we have two different algorithms for insertion and deletion in queue. So for insertion, we named it queue insert. Queue is an array and is the elements of an array. Front is a pointer, rear is also a pointer, an item which we want to insert into the queue. So this procedure inserts an element item into a queue. What does this algorithm do? This algorithm will insert an item into a queue. So first we will check if a queue is already full. For example, we have n elements and all the elements are filled, then we cannot insert the element in the queue. That is, if front equal to 1 and rear equal to n, we have front at 1 and rear n, or we have front equal to rear plus 1. So we call this condition overflow and return. Yeah, we cannot insert an element in this because our queue is already full. So if the first condition is not true, then if front is null, if front is null, it means we have an empty queue. We don't have any element in the queue. So we will set front equal to 1 and rear equal to 1. Else if front equal to n, if rear equal to n, that is if we have rear at n, then set rear equal to 1. Else set rear equal to rear plus 1. So this is how we will set the value of rear. Then we will insert the item in at the rear. So queue rear equal to item, we will insert the item which we want to insert the queue at the position rear. So this inserts new element and return. So we have to understand the first condition. First condition is we have our queue already full, that is front equal to 1 and rear equal to n, or front equal to rear plus 1. So we call this condition overflow and exit. So if First condition is not true. Then if front equal to null, if front is null, it means our queue is empty. So we will set front equal to 1 and rear equal to 1. Else, if rear is at n, so rear is at the last point, then we set rear equal to 1, or we will set in normal condition, we will set rear equal to rear plus 1. So next, at this rear pointer, we will insert the value, that is q rear equal to item, then the this inserts new element and return. So this is how we can insert an element in a queue. So next is delete. So how we can delete an element from a queue? So we have a queue with n elements. Front is a pointer, rear is a pointer, n is a variable in which we will insert the value. We will assign the value which we want to delete. So first we will check the underflow condition. Underflow condition is that condition where we don't have any element in the queue and we want to delete the value element from the queue. So if front equal to null, then write underflow and return. If front equal to null, it means we don't have any element in the queue. So we call this underflow and return. Second is if set item equal to queue front, set item equal to queue. So front, so we will assign the front value to item. If front equal to rear, if front is equal to rear, it means this is the condition which we have only one element. The queue has only one element into start. So set front equal to null and rear equal to null. If you have only one element, we have deleted that element, then then our queue becomes empty. So in empty queue is front equal to rear and null and rear equal to null. Else if front equal to n, if front is at n, then we will set front to 1, or in normal condition set front equal to front plus 1. So this is how we can delete an element from the queue. So first condition is underflow. Underflow is when we don't have any element to delete and we try to delete the element, that is called underflow. Then we will assign, if this condition is not true, then we will assign the value at front to item. Then we will check if front equal to null, if front equal to rear. This condition occurs when we have only one element in the queue. So when we delete that element, our front becomes null and rear also become null. That means our queue becomes empty. If this condition is not true, and if front is at n, then we set front to 1. If front is at n, we will set it to 1. Or if this condition is also not true, then the normal condition is front equal to front. We will increase the value of front by 1 and return. This is how we can delete an element from a queue. This is what I have today, that is the algorithm of insertion and deletion in a queue. Thank you.